All right, welcome to day 3 of Unit 5. In your homework planners, you can put packet page 23 to 24. You can also be working on the problem set, which is due Tuesday the 1st. And we're going to just do the warm-up together, so you can still put it right on your warm-up sheet in the Wednesday box, but we'll be doing it as a group. So true or false, the notation there means reflect point M across point A. The little a or little r does mean reflect. We are reflecting point M, but notice point A should be a capital A. So if you have a lowercase letter, that's actually representing a line. So this would be false. It is reflecting M over line A as opposed to point A. Because if you have a point, it is always notated with capital letters. What's the image of y equals -2 after reflection in y equals 1? So we'll sketch this out. So here's our x and y axis. We need to, by this point, be getting comfortable with the equations of vertical and horizontal lines. Y equals 1 means we should cross through the y-axis at 1. So if we're crossing through the y-axis at 1, it should look like that. And we'll put our scale in. Now you don't need graph paper to graph these. Okay, again, just space your scale out as well as possible. So we are at 3, -2, which would be right here. And we'll just count. We are 1, 2, 3 away. So we're going to go 1, 2, 3 away on the other side. And they didn't give us a letter, but let's say hypothetically this was A and this was A prime, just so we can tell which one is the original and which one's the image. So our image then would be 3, 4. Alrighty, if we go over to the homework, so it's kind of hard to show this, but what we've done here, just like we did in class yesterday, make any arc from the point that gives you 2 intersections. So like from this original point, did an arc, did these 2. Keeping your compass the same, do that same arc from each of them, and wherever they end up intersecting, that is your image point. Do that for all 3, and then connect your image points to get the full image. How many fixed points are there? Fixed points are ones that are on the line of reflection, so their image is exactly the same spot. There were no fixed points in this case. Here's another reflection we had to do. We had to reflect A over, do an arc, keep your compass the same, do the arc from both intersection points to get the image, the A prime. Same thing for B. And then C stayed put because it was on the line of reflection. So C and C prime are the same point. So therefore, we did have one fixed point in this problem. Line of reflection, take any 2 points, the image and pre-image, draw a line between them, and do the perpendicular bisector. That perpendicular bisector is your line of reflection. There's another line of reflection, same thing. Now you didn't necessarily have to pick the same reference points that I did, just need to pick any 2 corresponding points and draw that line in. Or should I construct the line with the perpendicular bisectors? 5 is pretty much same idea. Now you need to make sure you pick 2 points that aren't fixed points. So that one that is a fixed point there, you wouldn't be able to do the perpendicular bisector with just a single point. So you had to pick a different pair. So little r for reflection. Our subscript there is BC because that's what we're reflecting across, and then the point A in parentheses. And down in 7, this is telling us to reflect our triangle over line D because it's a lowercase d. All right, so we're going to be on page 17 to start out. We have 2 topics for today. We're going to look at point reflections, and we'll also look at translations. We are going to use our compass and straight edge quite a bit. So please take those out. If you need a moment to pause the video, go ahead, pause the video, and go get those. But we will need those in today's class. So if you want to reflect through a point, it's pretty easy. It's basically got to go a straight line distance to the opposite side of the point. So if we want to reflect P through C, the first thing we want to do is we want to use our straight edge, and we want to draw a line with our straight edge that goes from P and passes through C. Now you need to make sure that you extend it at least more than the distance that it is from P to C. Once we have that, we are going to take our compass and we're going to set our compass to the length it is from P to C. So put your point on C, or sorry, your point on P and your pencil on C. And then we're just going to pick up our compass. We'll now move our point to C, and we'll do an arc. And wherever that arc hits our line that we extended, that is where P prime would be. That is our image. And now we have reflected point P through C. So it just goes in a straight line through the point of reflection, the same distance on the other side, because we know reflections, you always go the same distance, but on the other side. And that's it for point reflections. Now we can get a little bit more complicated down to number 2. Now I shrunk my picture down into a little bit. It's the same picture you have, but just the smartboard compass only opens so wide. So I had to shrink mine down so that I would be able to do it. So we are going to reflect this through point D. So let's start out, maybe I'll start with point C. So we're going to draw a line from C through point D. And we're going to take our compass and we're going to put our point on C and our pencil on D. So point on C, pencil on D. Now put your point on D, make a little arc, and that'll tell us where C prime is. So we're going to repeat that now 2 more times for A and B. So start at A and use your straight edge to draw a line that goes straight through D. We're going to put our point on A and we'll put our pencil on D. And now move your point over to D and make your arc to determine where A prime would be. And we'll do that once more. We'll start at B and draw a line that goes right through D. We're going to put our point on B and we're going to put our pencil on D. Move your point over to D, make your arc, and that'll tell us where B prime is. Well, to finish it off, we just want to connect those image points, and that'll make our image triangle. And make sure you're using your straight edge to do that. Okay, so there's our image, A prime, B prime, C prime. Now the follow-up question asks if it preserves orientation. So what we want to do is let's start at A and go clockwise. If we start at A and go clockwise, our points go in the order A, B, C. We'll now go to A prime and also go clockwise. If we start at A prime and go clockwise, we have A prime, B prime, C prime. So notice the points are in the same order, so yes, it preserved orientation. We saw yesterday that a line reflection does not preserve orientation. That will end up being the only one that does not preserve orientation. All others that we see will preserve our orientation. So this is how you do a point reflection with a compass and a straight edge. If we go over to page 18, we'll see it on a grid. So they give us our pre-image. We've already got that triangle plotted, and we're going to reflect through the origin. Well, all you do is you count how you need to move to get to the origin and repeat it. So I'm going to start at A. From A, you go down 2 and left 3 to get to the origin. Well, we're just going to go down 2 and left 3 again, and that'll give us where A prime is. So you count how do you have to move to get to your point that you're reflecting through, and then repeat it, and that gives you your image. So we'll do B next. B is going up 5 and left 1. So we'll again go up 5 and left 1 from the origin, and that gives us where B prime is. Lastly, C, we're going up 2 and 6 to the right. So we'll go up 2 and 6 to the right from the origin, and that'll give us where C prime is. We'll go ahead and connect our points. And always check the question because a decent amount of time they'll want you to write the coordinates, and we are going to have to do it here. So A prime, we have -3, -2. B, we have -1, 5, because we went 1 to the left and 5 up. And C, we went 6 right and up 2, so that's 6, 2. Well, let's see if we can generalize what happened here. Let's start by looking at our x's. 3 went to -3, 1 went to -1, -6 went to 6. So it appears our x was always negated, so we'll have -x. Let's look at our y's. 2 went to -2, -5 went to 5, and -2 went to 2. Our y was also negated, so we have -y. So the origin is the most common point of reflection, but if we go down to the bottom of page 18, we can actually reflect through any point. So we're going to reflect EF through the point 2, 3. So let's go ahead and plot where 2, 3 would be. And just like before, how we counted how we need to move to get to the point and then repeat it, we'll do the same thing here. So let's start with F. F, we have to go up 6 to get to our point. So you just do up 6 from our reflection point, and that'll give us F prime. For E, we go down 3 and right 7. So we'll do down 3 from our point and right 7, and this will give us E prime. We'll connect those 2 points, and that is our image of line EF when it is reflected through the point. E prime, if we count our boxes there, we went 9 to the right and 0 up and down, so we have 9, 0. And F, we went 2 to the right and then 9 up, so we have 2, 9. So there's no fancy always rule for when you do a reflection through a point that's not the origin, because that point will change. So you see down below the graph there, it's just telling you count up and down, left and right to see how do you get to the point, and then repeat that process again to get to the image. So that's it for point reflections. We're going to go over to page 19 and start looking at translations. Translations, remember, are a slide. We saw that on day 1. Now, we determine what direction and how far to slide by a vector. A vector is just an arrow that has a specific length and is pointing in a specific direction. So that tells us how far and which direction to slide. So down in the picture here, this is showing us our vector from C to C prime. Really, you can draw the vector from any of the corresponding points. So we could have drawn the vector from D to D prime, B to B prime, A to A prime. It would be the same length and sliding in the same direction. So we want to know, does it preserve orientation? Well, let's start at point A here and go clockwise. We would have A, B, C, and D. If we start at A prime and go clockwise again, we have A prime, B prime, C prime, D prime. So those are the same order, so yes, it does preserve orientation. The one we saw yesterday is the one that will not, the line reflection. Down in the bottom, our pre-image is the solid figure, and the image is the dashed figure. And all we're going to do is we're going to draw our vector that shows the translation. So we're going to pick 2 corresponding points. Okay, and you can pick any 2 corresponding points. And you're just going to draw an arrow that goes from your pre-image to the image. So the point of the arrowhead point, should be finishing at the image. We'll do the same thing in B. Here's a point in our pre-image, there's a point in our image, and we'll just draw in our arrowhead that shows that slide. It shows the specific length we should slide and the specific direction we should slide. All right, so now we're going to do translations with the compass. These can sometimes be a little challenging. Okay, so if as we're doing them, if they're tricky, feel free to rewind back in the video and watch it over again, or as you're doing the homeworks, feel free to watch this portion of the video again. So the idea is we want X to slide the length of AB and in that direction. So you should be able to right from the start kind of predict where it's going to be. So like I can predict X prime should end up somewhere about there, because that would be sliding in the same direction as AB and going the same distance. But we don't want to just eyeball it. We want to find the exact spot using our compass and straight edge. But we know our answer should be somewhere around there. So the first thing we do is we take our compass and straight edge and we set it to the length of AB. So to do that, you're going to put your point on A and you're going to put your pencil on B. Okay, so point on A and pencil on B. Now what you're going to do is keep the compass the same, and we're going to move over to X. Put your point on X, and make an arc kind of in that general direction where we predicted X would shift to. So that's telling us how far it's going to shift from X. So that's always the first step. The next step is we need to set our compass to the length from A to X. So put your point on A, put your pencil on X. Okay, point on A, pencil on X. Once you have that, we're going to move down and put the point on B and put it right on the tip of the arrow. And then make your arc where those intersect. that's where x prime is going to be. So that slides point x in the same distance and in the same direction as vector AB. So to review, we put our point on A and pencil on B. Then we moved over to X and we made that arc going in the direction that we know it should slide. Then we put our point on A and pencil on X, moved the point over to B and made our arc to see where we'd get our intersection. Now you have those step-by-step directions down in 20. So if you prefer that as opposed to the visual of seeing it done out, you have that to help you on your homework. Alrighty, so let's go down. We're going to do number 7. We're going to translate segment AB by vector CD. So I always like to just kind of make a prediction. So if you're going to take A and slide it the distance of CD and in the direction, A is going to be around here, and like B is going to be around here. Okay, so we know that's where we should end up, but we want to find that exactly, so we'll use our compass and our straight edge. So to start out, we want to set our compass the length of our vector. So we're going to put our point on C, and we're going to put our pencil on the tip at D. And what we can do here is we can do our arcs from both A and B, one right after the other, because they both need to shift the length of CD. So I'm going to put my point on A, and I'll make my arc to tell me how far we should slide. And then I'll go and put my point on B, and I'll make my arc that tells me how far we should slide. So now for our other arc, it's going to be different for each point. We're going to put our point on C and put our pencil on A. And then we move that point down to D. And we make our arc. That intersection is where A prime will be. Then we put our point on C again, and this time we're going to put our pencil on B. Now we'll move the point over to D, and we'll make our arc, and that gives us where B prime is. So when you're doing the homework, on the translations with the compass, I should not see any I don't knows or I'm not sure, because you should have this video to go back to. If you're not sure when you're doing the homework, come back to this video and just watch the minute or two where we show you how to do the translations with a compass and straight edge. To finish this off, just need to connect with our straight edge to give us the segment AB. So we have slid AB, the distance of CD, and in that same direction. All right, if we move down to the bottom, we'll look at translations in coordinate geometry. So in other words, on an XY axis. There are two ways that you can notate a translation. The first one is shown there. It's saying take XY, and we're going to add 7 to the X, and we're going to subtract 1 from the Y. Now the other way that you could see it is with this capital T. So we could see T, 7 comma negative 1, and then in parentheses here what it is we're translating. We're translating triangle LNM. So these mean the same thing. They're the two different notations for the translation. If you add 7 to the X, that means you're going 7 right. If you subtract 1 from the Y, that means you're going 1 down. So as we slide these points, we're just going to go 7 right and 1 down. So let's start with L. We'll go 1, 2, 3, 4, 5, 6, 7 right, and 1 down, and that gives us where L prime is. You don't have to put those intermediate dots. That's just to help you see as you're watching how I'm counting. So go to n, we'll go 7 left and 1 down. So that's n prime. For m, we'll go 7 left and 1 down. So that's m prime. We'll connect those. And that's our translated triangle. That's our image. Now always check the question, see if we have to state the coordinates. There's nothing that says we have to state the coordinates, but you always want to look for that because that is sometimes the case. All right, our last page for today, 22. We are given the pre-image and the image. We want to write the transformation. Well, notice it's just sliding, so that would tell us it's a translation. And if you look at B, B went 1, 2, 3, 4, 5, 6 to the right, and it went down 1. So one way we can notate this is with our point, the x comma y. We can say x comma y and put an arrow. And we can say x plus 6 because we went 6 to the right, and y minus 1 because we went down 1. So that's one way you can notate it. The other way, we can do the capital T. We'll tell the translation, 6 comma negative 1. That means we went 6 to the right and 1 down. And then even with the T, we got to tell what is being translated. Well, for us, that's triangle ABC. So it said we had to do both types. If it just said write a rule, either one of those would be correct. Alrighty, last one. We want to translate the circle by this vector. Well, really, we know that the translated circle is not going to change its size, so it's going to have the same radius. So really, we just have to translate the center. So we're going to start out by setting our compass to the length of the vector. So I'm going to put my point over here, and I'll put my pencil, and it looks like I've got to shrink my figure just so that I can do it on the smartboard. Your compass should be able to open enough for the paper. So I got my point at the end, pencil on the arrowhead. So I know it's going to shift up and to the right, so I'll make my arc now up and to the right. I know it's going to be somewhere over there. Well, now I'm going to put my point on the end point of my vector, and I'm going to put my pencil on the center. And then I'll move my point to the end point of the vector. I'll make a little arc, and that's where my center of my circle will be. Well, to finish off the circle, I've got to set my compass to the radius of the circle. So I'll put my point on the center, and I'll put my pencil right on the circle. And then I'll come over to my intersection point, and I'll just make a full circle, and that's my translated image. It slid the circle the amount of the vector. So again, as you're doing these for homework, especially on the construction ones, if you're stuck, the expectation is that you go back to the video, skip ahead in the video. That's why I allow you to skip. So in instances like this, skip ahead to where we go through the constructions for transformations and use that to help you out. Have a great rest of your day.